Good afternoon, everybody. Welcome to class today. Thank you for joining me, whether you're watching live or you're watching the recording. I appreciate you watching. This is wrapping up week 2 of Module 7. And in Module 7, we're looking at the concept of loops. And last week, I gave you all a bit of a pre-recorded video that examined loops and loops of different types. And this week, what I want to primarily do is just kind of do some demonstrations, just walk through some different, programs or different use cases for loops, and just kind of show you how things work in practicality in Java with a loop. So what we typically see with a loop, right, is we'll typically see a single action done multiple times, which, if you watched the video last week, which I recommend you go back and watch if you did not, we might see something like a public static void print numbers, and then we write our for loop, which would just be something like for int I equals 0, I is less than or equal to 10, I plus plus, and then we can system.out.print line I, semicolon at the end, and then we call that print number function in our main method. Right, a pretty standard operation here, right? We're just counting from 0 to 10. If we run this, we should be able to see from 0 to 10 get counted in our console. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And so when we break this down, what we're seeing in our loop definition here is we have a starting point in our counting, I equals 0. An ending condition here, I is less than or equal to 10. So this is only going to work as long as I is less than or equal to 10. And then finally, we have incrementation, I plus plus. I is 0. Since 0 is less than or equal to 10, we run the code and we add 1. So then I becomes 1. 1 is less than or equal to 10, so we run the code. I becomes 2. 2 is less than or equal to 10. We run the code. I becomes 3. And so on and so forth. So what we see here, right, is we basically see a starting line, a finish line, and the ability to take steps from the starting line to the finish line until we finish the race. Right, so this type of loop where we know how many steps we need to take is called a definite loop. A definite loop, right? It's clearly defined. It has a beginning, it has an end, and it has a number of steps it takes to get from the beginning to the end. There's also a type of loop that we use that's called an indefinite loop, right? In an indefinite loop, we don't necessarily know how many steps it's going to take us to do something until we get to the end, right? So in this case, we typically have some other type of input, right? So in this case, we might need to use a scanner. So we might want to say import java.util.scanner. That's uppercase S scanner because scanner is a class. Let us add our scanner at the class level. So scanner public scanner in equals new scanner on system.in. So now I have a scanner object that I can use across multiple different methods because my scanner object is public. The access modifier is public, so it can be accessed in multiple different functions across this same class. So if I were to public static void print name, right, we can, since scanner is non-static and the function that we're making here is static, we would probably want to create an instance of scanner. So we'd want to instantiate our class in here. So I'd want to say something like main obj equals new main. That way we can instantiate our class and use that public scanner that's at class level in our function. And so in this case, we would be doing an indefinite loop to where we could say something like while true. And while true is going to be in parentheses here. And then our curly braces. While true, we can say system.out.print, enter a name. If, or then we have to take the name in, so we could say something like string name, or we'll say user name equals new string in dot next line. And we can't access in from this static method, so it would have to be we would have to use our instantiated class here. So we would say something like obj.in.next line. Right, so now we would need some way to get out of this, right? Because we can't just do this in an indefinite loop, or else it would run forever. And then at some point we would get what we call Stack Overflow, which would be, if we had an infinite loop here. In which case, right, not very good for us. It's going to crash our program. So we could say something like, if username dot equals Mr. Ramsey. We'll do that. We'll say system.out.print line hello Mr. Ramsey, and then we will run a break statement. And that break statement is what is going to break us out of this indefinite while loop. Right? So once this condition is deemed true, and it runs this code inside of this conditional, it's going to trigger this break statement, which is going to break me out of this while true loop. We can else say maybe system.out.print line, enter another name. Right, and so now if we call that function, if we call that print name function, it's going to allow us to do this activity multiple times of just entering a name. Right, we can just enter as many names as we need to enter here. But when we enter in the key name, which is the one that we defined in our conditional statement, it returns the trigger. So we see different ways of doing different things here. And really, we could get like the same sort of result out of a definite function and an indefinite function, which is one of the interesting things that we can kind of do with an indefinite function, right? Like maybe I want to look at this and I want to say, well, what if we had some other value here, right? Like what if, okay, what if you entered Mr. Ramsey, but we didn't necessarily want to do it if you entered Mr. Ramsey initially. We wanted to do it after you enter Mr. Ramsey 3 times. Right, so typically what we would do here is we'd create some sort of counting variable. So I'll create an integer variable c and set it to 0. And what we'll do here is we will nest an if statement. We'll cut that code out of there really quickly, and we'll nest an if statement. And we'll say something like if, or actually I'll go ahead and just increment c there. So if username equals Mr. Ramsey, we will increment c. If c is 3, then we can do this thing. I could even take it and say something like, system.out.println. That's, and just concatenate that with the value of c. All right, so that way it could say like that's 1, that's 2, that's 3. Hello, Mr. Ramsey. That sort of thing. Right. So now if we run this at this point, and I tell you what, let's stop this and let's clear out the console before we run it. We're entering names, right? We can enter whatever name that we want. And we can kind of see, okay, well, based on what it's triggering in our code, we enter Mr. Ramsey 1 time, it says that's 1. We can enter Mr. Ramsey again here, it'll say that's 2. And a 3rd time, and that's 3. And hello, Mr. Ramsey. So if we see something like that, right, like we can kind of see maybe how some things like our lab assignment will work, right? Like with our rock, paper, scissors simulator. To where, you want to win 5 in a row, but if you don't win 5 in a row, it'll reset to 0, something like that. Right? And if we look at our, program here, right? Like all we would really have to do to get it to make sure that it's 3 in a row is essentially just taking and on the else condition, reset C to 0 if that is triggered. Right, so now we have this indefinite loop here. It's going through, it's looking for me to enter Mr. Ramsey. If I enter Mr. Ramsey 3 times in a row, that's going to set C to 3, and that's what's going to print hello, Mr. Ramsey. But if I stop and enter in something else in the midst there, it's going to print nothing, right? It's going to reset the value. So we start to type in some names, right? We type in, say, James and Sarah. Right, so we're still triggering this here, and we're triggering all of this here, right? We're resetting C to 0, and we're saying system.out.println, enter another name, which it's fine at the beginning because C is always 0, but if I enter Mr. Ramsey, that's 1. If I enter Mr. Ramsey again, that's 2. But if I were to enter in something else here, right, that wasn't Mr. Ramsey, it's going to hit that else condition. It's going to trigger C equals 0. So it's going to reset C to 0 again and tell me to enter another name. Right, so if I go back and hit Mr. Ramsey again, it starts to be back over at 1. Right, so that's ensuring that I do 3 in a row. Which is pretty, it's pretty cool, right? Like, we have this ability to see if something happens, if it doesn't just happen, if it happens 3 in a row times. Which is incredibly useful for a lot of applications for us, right? Like, it could be for this sort of thing. It could be for, sensors, right? Like, if we have a sensor that's keeping a reading, maybe if we are taking incremental 15-minute readings, and in 15 minutes it's at one level, in 15 minutes it's at the same level, in 15 minutes it's at the same level still. Like, if the level's the exact same for 3 incremental 15-minute periods, then maybe we tell it to wait an hour or wait 2 hours before the next reading. That sort of thing, right? And so if we kind of look at this in relation to our rock, paper, scissors, we're essentially sort of doing the exact same thing, right? Like, in an earlier module, you all did the rock, paper, scissors, and we can kind of do a little proof of concept RPS here, right? Like, we have our we would need to be able to do our random numbers, right? So in Java, we're going to import java.util.random. And we're going to need to make a new random object. And so we could do that in the exact same way that we do our public scanner class here, or we could do it in the method itself, right? The way that most of you all did previously. So I could say something like public random r equals new random. And now I have a new object of the random class. Right, and so one of the interesting things that we can do with random numbers is we can cheat. Right, so if I were to make a rock, paper, scissors function, let's just do it right here. And I made, say, a public string RPS. And we return our stub of an empty string. So at this point, what we have is a public string function. So it's going to return some kind of string. It's called RPS. Random is public at class level. We did not make this function static, which means I don't have to make an object here like I did here for this static function. So I could just create a new random number. And I could just use scanner here. Now, one of the interesting things about cheating and the way that I'm talking about it here is kind of the way that we get our numbers, right? And using probability to our advantage. And this is where we get into some of the things that, like, video games will do, something like that, to make something more favorable to one way or another, right? So, as you all probably did when you did this earlier on, you probably said, okay, well, we're going to do rock, paper, scissors. That's 3 values: rock, paper, and scissors. So if we had a random number generator pick from these 3 numbers, right? Typically what we would do is we would put in 3, but then the numbers that we would have would be 0, 1, and 2 for R, P, and S. It's not quite that, because there's no such thing as true randomness in programming, but we're pretty close to an even 33% chance, 33.3 and continuing percent chance between all 3 of these values. If I wanted to rig things in my favor a little bit, or if I wanted to change things up just a little bit, one of the things that I could do is use a bigger set of values, right? So maybe instead of 3 values, I use 100 values. And in the case of 100 values, I'm getting numbers from 0 to 99. And so this is where I would start to take advantage of numerical ranges. Right? So I could say that instead of rock being one number, it being a 0, I could say rock is 0 to 10. I could say paper is 11 to 30. And I could say scissors is 31 to 99. Now, there's still some numerical randomness here, right? But the distribution of our ranges here means that scissors is going to occur way more often than rock or paper. And so ideally, if I was doing this, right, I would actually change this up a little bit and do something like comp choice here. And then we could say something like, we'd get our random number. So we'd get some sort of random number here, like, let's see, it would be random, or it would be ran num equals r dot next int, right? And we need to make that an integer variable here. And then we would just have to determine what that value is. Right? So we could, just make a chained conditional here and say something like if random is greater than, or actually we could just say if random is less than or equal to 10, then we would return rock else if random greater than 10 and ampersand random less than or equal to 30, we will return paper, else we will return scissors, and then we can get rid of that return statement because we have a return coming out of all of our paths. Right, so if we were to write a little bit of a loop here, and we could say something like for int I equals 0, I is less than or equal to, or we'll just say I is less than 10, I plus plus, and then we will want to call comp choice. Well, we'll want to print it, so system.out.print line comp choice. But 2, that is a non-static method that we are calling inside of a static method. So we need to do a little bit of instantiation. Main O equals new main. So this becomes O dot comp choice. And so now, based on those random numbers that get generated as this function runs, we'll get a different value every time, right? And so let's see what prints out. Rock, rock, scissors, 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 rock, scissors, rock, scissors. Right, which makes actually not a ton of sense, right? Because paper still should return more often than rock, because there's a 20 number distance there between random and between the paper condition and the rock condition. But that does still go to show you that there is some randomness here, and we do see that scissors gets drawn more often per capita, which is, that's kind of wild right there. We got a bunch of rocks. It'd be interesting if we actually return the random number with that as well. So in order to do that, we would want to concatenate. So we do like rock space, paper space, scissors space, and we would concatenate that with the string typecast value of the integer. So it would be something like plus random dot to string, boom. And actually, I think what we should do here instead is actually integer dot to string random, something like that. Right, that's what happens when you program in too many different languages. So now if we do this, we can actually see the number that gets pulled along with the text rock, paper, or scissors. So if we were to run that, we see the values that we get. And now we start to see why we're getting these values, because we forgot to include a number here in r.nextend. That should be 100. And now we should start getting things along a little bit of a better line. So we see that's making more sense now. Right, because in the condition that we made for ourselves there when next int was infinity, we had negative infinity numbers below 0, which would fall into the rock category, and positive infinity numbers above 30, which would fall into the scissors category, but it would be very, very, very rare if we ever had a paper show up. Right, and so now we could probably run this a few times and see it happen. Right, we're seeing that it's picking scissors more often than not. There it picked paper, right? And so this is one of the things that we can kind of start to do to manipulate things and play things in our favor, right? Like if we were to add a little bit of intelligence to this program, one of the things that we could do is say if we noticed the player pick the same rock, paper, or scissors multiple times in a row, then we change values up to where we give more weighting to something that would make them lose, right? Like, and we just do that with variables and with another counting variable similar to what we did down here, right, where we were counting. So if that counting variable got to 3 or 4 and they were putting in multiple rocks in a row, if I wanted to try to prevent them from getting to 5, I could throw something in there that would shift the weighting to where rocks would be lower weighted and scissors would be higher weighted, or something like that, right? Lots of things that could be done there. In order to change things up. And so we could kind of do something here where like we were getting a comp choice, and then we also had a public string player choice. And we're going to return our empty string as our stub. Right, and in this case, all we would really want to do is to use our scanner class. So we could do something like, string, or something like system.out.print rock, paper, or scissors. Take the value and return it back to some variable. String x equals new string on n.next line. And then we just return that temp variable there. And so now we have two values here, right? Like we have a player choice and we have a computer choice. And so we would just need some other choice that would compare them. And then another function that would do kind of what we were doing down here at the bottom. And using this while true with a counting variable to run these functions together. So I might do something like say public Boolean RPS match, and we do a string player and a string computer. And we probably wouldn't want to do a Boolean here just because there is a third condition that would mean something different than our true or false. So we'd probably want to do this as a string instead. So we'd say something like if p dot equals C, we'll return tie. All right, and that should be a parenthesis instead of a curly brace. Fix that up. Else if, say, P equals rock and C equals, and these should be dot equals instead of equals. P dot equals rock and C dot equals scissors. Or, right, notice the condition here, the way that we have it set up. Right, since all of that is in a parenthesis, and a set of parentheses, and that's all one big long compound condition. We can kind of copy and paste that and just switch. The scissors cut paper, and paper covers rock. In which case we return player win. Else we would return computer win. Right, so now here we could run our PS match. O.RPS match. Player choice is O.player choice. So P is O.player choice. And C is O.comp choice. We'll clean this up a little bit here. And that is player choice is a function, so we need to make sure to add our parentheses there. So now if we were to run this, oh, we got an error here. Where is my error? Oh yeah, I got a bunch of parentheses in there. I need one extra one. So it's asking me rock, paper, or scissors. I'm going to pick rock. And I get a computer win. I can pick paper. I get a computer win. I can pick scissors. And if I start to pick scissors here, I should get and let's see. I should play rock to try to keep getting a win. And there's the player win. Right, so if every time we got a player win, we took a counter variable and we added 1 to it, then at that point, right, we're doing something to where we could kind of keep track and see if they're winning multiple in a row. In which case, we would be able to count and do the lab assignment and see what could be done there. All right, so that is where I think we are good enough to stop for today. All right, I think we are prepared with some examples here now, and we should be able to handle the lab assignments as they are thrown at us. I will give you all this this file here that you can use for your reference. And that's all that I have for you for today. If you have any questions, please send me an email or a Teams message and let me know. Thank you for watching. We'll see you next time.